Lines that shape our world, parallel and perpendicular. Think about our transport system, specifically train tracks. When train tracks are laid, they must be perfectly parallel. Why is that? If they aren't, we face serious consequences, a derailment. This isn't just a minor inconvenience, it's a safety hazard. Imagine the precision required to keep these tracks aligned, ensuring safety and efficiency in our daily travels. Imagine the precision required in architectural designs. Now, consider the building pillars. If these pillars aren't perfectly perpendicular to the ground, the consequences could be dire. The entire building could collapse. This highlights the importance of accuracy and precision in construction, and how even the slightest deviation can lead to catastrophic results. Let's move forward to understand how we can construct precise parallel and perpendicular lines using simple tools like a compass and a ruler. What are parallel lines? Parallel lines are lines that exist in the same plane and run alongside each other. No matter how far you extend them, they never meet or cross paths. Imagine the tracks of a railway or the opposite edges of a ruler. These are practical examples of parallel lines in real life. What are perpendicular lines? These are lines that meet or cross each other at a right angle, which is precisely 90 degrees. Imagine the corner of a piece of paper or the intersection of two streets forming a perfect T shape. Those are examples of perpendicular lines in action. How to construct perpendicular lines step by step. Step 1. Begin by drawing a straight horizontal line on your paper. This will be your baseline, and it must be perfectly horizontal. Once you have your line, label the endpoints as A and B. Step 2. Set the compass width. Make sure it's wider than half the length of segment AB. Place the sharp point of the compass firmly on point A. This will be your anchor point. By doing this, we're preparing to draw arcs that will help us find the midpoint of segment AB in the next step. Step 3. With the sharp point still on point A, you'll swing an arc above the line segment AB, and then another arc below it. Once these arcs are drawn, we will be ready to move on to the next step. Step 4. Here, you'll want to maintain the same compass width that you used in the previous step. This is crucial for accuracy. With this compass width, repeat the process at point B. Swing an arc above the line, just as you did earlier. The key here is consistency. Keeping the same distance ensures our figure remains precise and symmetrical. Once you've drawn this arc, you'll notice it intersects with the arc you drew from point A. This intersection above the line is what we'll refer to as point C. Mark it clearly, as it becomes an essential part of our construction. Now, repeat the process on point B, just as we did earlier. The goal here is to create intersecting arcs below the line segment AB. This intersection will be marked as point D. By doing this, we are setting up the foundation for creating a perpendicular bisector, which will be the focus of our next step. Step 5. Begin by placing your ruler along the 2 points where the arcs intersect. These are the points you've marked as C and D. Once your ruler is properly positioned, draw a straight line connecting these 2 intersections. This line will serve as the foundation for the next part of our construction. Take a moment to observe the diagram. Notice how line segment CD meets line segment AB exactly at a right angle. This intersection is crucial because it ensures that the 2 segments are perfectly perpendicular. Welcome to this next step, constructing parallel lines. Step 1. Start by taking a ruler and drawing a neat horizontal line segment. This will be our foundational base. Label the endpoints of this line segment as E and F. In step 2, we're focusing on marking a new point, point G, that is not on the original line segment EF. Before we proceed, let's talk about a transversal line. What is a transversal line? A transversal is essentially a line that crosses 2 or more other lines at different points. In step 3, we're going to draw a transversal line. First, make sure you have your ruler ready. Now, carefully place the ruler so it crosses through point G and intersects line segment EF. Once your ruler is aligned, draw a straight line. This line should intersect EF at a new point, which we'll label as point H. Step 4. Using a ruler, draw a horizontal line through point G. This line should be perpendicular to line segment GH. The key detail here is ensuring that the line is perfectly horizontal and intersects point G at a right angle to segment GH. In this slide, we are focusing on the relationship between line G and line segment EF. Take note that line G is parallel to line segment EF. Why do engineers and architects rely on parallel and perpendicular lines when designing buildings and roads? First, parallel lines are crucial because they ensure uniform spacing. Pause for a moment. Think about roads or railway tracks. Parallel alignment guarantees that these paths remain consistently spaced apart, allowing for efficient and safe travel. On the other hand, perpendicular lines are vital for providing stability. They create right angles, which are the backbone of strong and reliable structures. Imagine the corners of a building, needing that perfect 90-degree angle to stand firm and withstand various forces. Remember, these geometric principles aren't just theoretical, they're practical solutions that have stood the test of time in engineering and architecture. Thank you for watching. Subscribe, like, and share. Follow me for more learning videos or comment below.